In this session, we're going to talk about the elements of a software design description. As you remember from the planning video, there are three parts to the software design document: a general system description, the detailed design, and some test values. In the next couple of slides, we're going to take a look at each of these three sections in a little more detail. The system description comes first, and it has three major parts: the system overview, the platforms, and the interfaces. The overview is a high-level description that explains what and why you're programming. So it's very similar to what we did in the system requirements specification. Here, it's a little more detail than we provided there. In the platforms section, we need to talk about the systems we have available for development and for execution. So in terms of development, we want to specify both the hardware and the software that we're going to be using to write the application. But we also need to take into account the hardware that's required for the execution that the user will do. So we might develop on a PC, but we might be writing an app for an Android device, for example. The last part of the system description is about the interfaces. So what we're going to start with is another block diagram. And this diagram is going to show the flow of data between the major elements that we have. So we're going to show that the input module, for example, is going to transfer certain data to the processing block. The processing block will transfer data to the output. So what we're going to show is the data and its type. So if it's a floating point number, we're going to specify that. If it's an integer, we're going to specify that. And with this diagram, someone else can look at it and see the general flow of information that has to move within the system. After we've completed that, then we're going to start sketching what the user interface is going to look like. If we're doing a text interface, it's not as complicated or complex as it would be if we're doing a graphical user interface. But in both cases, what we want to do is show what's going to be on the screen that the user is going to see on the input side and on the output side. The detailed design is the heart and soul of our planning process. It's got three major parts: a hierarchy diagram that shows the relationship between each of the subtasks that will be in the system, and then for each of those subtasks, its basic information and its algorithm. So let's start with the hierarchy diagram. So what we have here is every single module or subtask that is required for the system to do its overall job. It's going to be a series of boxes, so it's going to look something like this. So we're going to start with the top module, and then we're going to show each module that's required to complete the task. This would be our main module. This would be one that calls two other modules. So each of these would do a specific task and generate some information that this module requires. This one might pass some information back to main, which could then pass it into here. This might be a processing module that calculates some results for us, passes those results back to main, which is displayed and possibly printed. So in this one, we would have 1, 2, 3, 4, 5, 6, 7 modules in our hierarchy diagram. Therefore, we would have 7 pieces of basic information and 7 algorithms. So for each of these boxes, say for example we're looking at this one, our basic information would start with the purpose. So what is its main task in this process? Then we would specify all of the input variables and the type of each of those that this particular module needs in order to do its job. Finally, we're going to provide or specify the output that this module is going to generate. Sometimes there is no output, sometimes there is no input, sometimes there's both. In any case, we need to consider what type of information it requires to do its job and what kind of information it actually produces and returns back to the system. Once we've defined the basic information, then we're ready to specify the actual logic. The two main tools we have to do that are pseudocode, which is an English-like representation of the process, or flowcharting, which is a graphical representation. Both of them are going to show exactly what's required in order to accomplish each of the tasks in our hierarchy diagram. The last part of our detailed design is the definition of our test data. And we need to remember to define test values to account for reliability, robustness, and any exceptions. So if we look at reliability first, we need to at least have test values for the lowest valid input that's acceptable. We need to have something in the mid-range of acceptable values and the highest value. We would need each of those three for every variable that is input into the system. This is going to ensure that our program always operates properly given appropriate data. Then we need to set up a set of test values to make sure that it's not going to crash if by chance it gets some invalid data. So we would choose a value just below the valid range, another value just above the highest range, and any other expected but incorrect values. So what we're going to look for here is what kind of error messages are we going to see if that happens. In the case of reliability, what kind of output are we going to get? Are we going to get the correct number? The last type of test value are exceptions. And here it's things like, do we have anywhere in our algorithm that we might result in a divide by zero error? Because we know divide by zero is undefined, and a computer program can't handle anything that's not defined. So we need to be proactive and make sure that that doesn't happen. Similarly, if we're expecting an integer value and we get a character instead, or expecting a name and we get a number, we have to have some way of preparing the system to handle those. So it's important when we're thinking about testing, we test for reliability or valid input, robustness, incorrect input, and any exceptions that might occur in our program. So in terms of our software design document, we have an overall description, we have our actual design, and we have a set of test values.